In this video, on lesson 3.3, rules for differentiation, we will be going over various shortcuts or rules that has to do with finding the derivative or differentiating constant functions, power functions, polynomial functions, some rational functions, the products of polynomials, and even root functions. So we'll see that. Okay, we'll start with the idea for finding the derivative of a constant function, first of all. So how do you find the derivative? Well, let me start with an example. If you're given a constant function like f of x equals 5, or f of x equals 10, or f of x equals 2, these are examples of constant functions. Graphically speaking, your equation, your function rule could be interpreted as y is equal to 2, which means your y values are 2 no matter what the x value is. The y value doesn't depend on the x value. And to find the derivative of that, the derivative of the slope of the tangent line, in other words, would be the slope of this horizontal line, which would be 0. So just graphically, we know that the derivative of this particular constant function is equal to 0. And as you could probably predict, no matter what the y value is, no matter what the function's constant value is, your derivative for that would be 0. Okay, and here's a little proof for that. Okay, so let me erase this part for now. So why is that true? Okay, because we know that the derivative is defined to be the value of the limit as h approaches 0 of f of x plus h minus the f of x all over h. But in this case, we're dealing with a constant function. So what that means is your f of x will be that constant value no matter what that is. And again, that constant value doesn't depend on what the input value is. So this part in turn, your y value will be c no matter what the x value is. So you got c for the first part of the difference quotient. Okay, f of x plus h becomes c, f of x becomes c. So in turn, you're going to have c minus c over h, and you're evaluating this, the limit of this, as h approaches to 0, and this becomes 0 divided by h as h approaches 0, but then you could simplify this part, 0 divided by h, first before evaluating any limit of that. So it becomes a limit of 0, and that limit of 0 doesn't depend on whatever the h value is, so your final answer is 0. So there's a little proof, okay, for why the derivative of a constant function is equal to 0.